Welcome to the first distinguished lecture of 2010 for the Environmental Energy Technologies Division. It's a great pleasure and honor for me to welcome Professor Sweeney. Most of you know him well enough that it doesn't need the full extensive introduction here. All I need to say is Surabhi tells me as a host, she's been getting an extraordinary number of requests from campus and outside of LBL for permission to come up to listen to him. Jim is the director of the Precor Center for Energy Efficiency, and he's a senior fellow for, I count, 8 different institutions or centers within Stanford, and has had an extraordinarily distinguished career in analytical studies on energy, natural resources, and environment. So without further ado, I would like to request Professor. I have one more pleasant task to perform before he speaks, which is to give him a framed plaque of the notice that has been put up all over the place. But this is a memento, a small reminder.
Thank you so much, Aisha. If I move, my microphone creates all sorts of sounds. It's a really pleasure to come here. I think about my interactions with LBL going back to times where I used to have debates with Mark Levine or Lee Shipper, and we'd agree on some things and wouldn't agree on other things, or Alan Sandsted. And it's just been a very long time where I've had just been a wonderfully positive relationship. And when as an academic, what I think about debates is that's good. You know, you agree on some things, don't agree on other things, and you all learn when you're debating and discussing with very smart people. And that's always been my image of LBL. And so it's just a delight to be able to come here. I'd like to talk about some issues in energy efficiency, and a lot of these same issues come up in renewables. And then the blurb that said what I was talking about probably gave equal weight to renewables and energy efficiency. And then I got realistic about how much time I had to talk. So I'll focus on energy efficiency, but many of the issues are just as relevant for where the consumers are choosing the renewable forms of energy. We all know, I think we all come from some of the same starting point, and I'm not going to dwell on it, that as we consider energy policy, there's really 3 different drivers. And it's the environmental protection, the international security, and the economics. And different players in the policy debate put different emphasis on those different things. You may have some correlation between political parties as to where the emphasis is. I'd like to think, though, that none of these should be essentially Republican versus Democrat, but issues of significant attention, both worldwide and for our nation. So what I want to focus on is recognizing that there's the first 2, the environment and security, have not been integrated fully into the markets that we deal with, where the economic issues have been more fully into that. So I want to focus on energy efficiency. I want to start with a definition, because my definition is different from what a lot of ones that other people use. I want to focus on 2 elements. reductions in energy intensity or energy use, but also on those that are economically efficient. It's easy if you've been working in the energy area to slip into an energy theory of value. Everything that uses less energy is good. Everything that uses more energy is bad. Nobody actually believes that, but language sometimes slips into it, and the thinking slips into it. And I'd like to make sure that, from the perspective I'm giving, is want to pay attention to how that we get the reductions in energy use that are economically efficient, for which the benefits exceed the cost of making the change. So what I'll talk about when I use the word energy efficiency, I mean those economically efficient reductions in energy use or the intensity of energy use. Which also means that there's some things which involve reduction of energy use that I wouldn't advocate. I don't think the benefits exceed the cost. Right now we have the use of the computers and the projectors which use energy, and I guess we can say, well, we'll get rid of that use of energy right now, but I'd like to believe at least that the benefits exceed the cost of being able to have pictures here. So to make it really drive the point home, we can think of two separable concepts: decreasing energy use and increasing economic efficiency. And what I think of energy efficiency is this upper right-hand corner where we do both of them. And there's a lot of things here where we want to think about being able to use energy for very important elements, and we want to sort of avoid the things on the left-hand side. So it's easy to start that with a definition. The question is, are there actual things, and many things, that come into this green box, the upper right-hand corner? And I just have a graph that I use just starts labeling a group of things. This is not meant to be exclusive. The number of things I put in the upper right-hand corner are chosen to be such that people can actually read them, so I was limited to the number of ones I could put in here. And I've color-coded them. In my judgment, and you can argue about the judgment, but in my judgment, the things in the right-hand corner can be energy efficient. The things down here are changes that use more energy but was good to do. And I've color-coded them. The yellow are things that new technological advances are probably going to be important to take the full potential there. So I think we could think about at some time plug-in hybrids with technological advances, fundamentally in batteries, what is needed to make them economically efficient, really, to go into widespread use of hybrids. That may happen, but without those technological advances in the batteries, it's somewhat dubious to me whether the benefits exceed the cost. LED is light-emitting diodes. I think that's going to be the next revolution in lighting. But right now, they're not cost-effective to go for general-purpose lighting. But anybody who has a bicycle light and uses one of those, you know that's a very cost-effective way of using high-quality lighting, and flashlights and many other ways we use LEDs. Optimized building construction. I talk about that involves new technology. A lot of the technology is a sort of software technology, and again, this is something that LBL's pioneered in with building software that allows the designers to understand the energy consequences of their building and begin to optimize. However, for the most part, we know that those softwares have a long ways to go to both be accurate description of the actual use of the building, given that human beings are going to be in the building, not just mechanics, because human beings behave differently often than is in those models. But you need new technology issue development. And I'll talk a little bit about smart meters and feedback. We're now just introducing smart meters for electricity. We've done almost nothing so far to understand what feedback can go to humans to cause the humans to choose to use more or less energy as a result of that feedback. So new technology is good. The light green is things for which we've had legislative changes, and you needed legislative changes to change the market structures and institutions to cause more energy efficiency. Take the reformation of the corporate average fuel efficiency standards, the CAFE standards. It's one in which not only we made the standards tighter, now we're integrating cars and trucks and getting rid of those perverse incentives that led the PT Cruiser to be defined as a truck for the purposes of the corporate average fuel efficiency standards. You know, it had enough clearance and it had enough cargo space that it could be defined as a truck. And there was a big incentive, a behavioral response by the manufacturers to redefine cars in a small way to call them trucks, so that now half of what we think of cars are actually trucks under the CAFE definition. So we needed those new regulatory reforms. The dark green are things that you need new legislative or regulatory changes that really haven't happened yet. People are talking about it, but may happen in the future. Really, congestion pricing happens in some places, but not nearly as much as we could use it. We talk a lot in California about smart regional land development, but we don't do much about it yet. We're now just putting in place incentives for counties to do it. And the white are things that don't require legislation, regulations, or new technology, simply behavioral changes. What individuals can do, and that can be significant. Like Obama and the campaign talked about tire pressures of cars. He got leaned by the Republicans on that, but the Republicans were wrong. It matters. Doesn't need new technology. It doesn't need new laws or regulations. Just needs people to come in and check their tire pressure and fill it up. Compact fluorescent penetration. That's decisions of humans to implement technologies. It's a sort of behavioral response. Efficient AC-DC converters. All of the electronics we use run on direct current. We plug it into an alternating current in the wall, and we have a little AC-DC converter. It doesn't really cost much to make those smart, so that when you don't need the electricity, they're not still using it, but you buy a lot of dumb ones, very linear ones that still use energy. That's a behavioral response because most consumers don't have any clue about what the AC-DC converter is, so there's not an incentive for the manufacturers to make the change. So the point I'm having here is that when we think about energy efficiency, we want to go back and understand that there's a lot of different flavors of what you may need for energy efficiency. Some of them involve technology, some laws and regulations, some involve just human changes, human behavioral changes, and it's worthwhile paying attention to those. Now, you've all seen this. This happens to be curve that Vattenfall has put together, and the horizontal axis is carbon dioxide reductions in gigatons of carbon dioxide equivalent per year. And the vertical axis is the cost, and measured in euros per ton of carbon dioxide. And the negative ones are things that are negative cost, and the positive ones are positive cost. And what we see is that, at least in their judgment, look at some of the names, is insulation improvements, fuel-efficient commercial vehicles, lighting systems, air conditioning, water heating. It's almost entirely on the demand side. On the demand side that we have negative costs that they estimate, and positive costs for things like capturing of waste, avoiding deforestation, solar, a lot of the supply side options. McKinsey, you've seen the same thing. No surprise because McKinsey worked with Vattenfall to develop the curve, so a lot of the same information in it. This is not their latest version, but we again see that concept. My own work with a group of my students, actually my undergraduate and graduate students, putting this together for the state of California for implementation of AB 32. Similar sort of things, only I thought that it's useful to take one more dimension. It's saying, of these things, what are those things that will be very responsive to carbon prices, the price system, because in those things that are very responsive, then we don't have to pay a lot of attention to regulation and others if we get a carbon tax system in place, and we can use the economic incentives associated with those. Now this isn't good enough. Okay. Is the pointers on it? Oh, is this is a. Oh yeah, that's right. I should. And so a lot of these green ones, like the wind electric and solar thermal, if you got the prices right in these renewables, had carbon, there's not a lot of market failures, and the market will be. Actually, there are some market failures, but the market can be quite responsive. Some will be some partially responsive, conservation tillage, for example. There's others that are sort of minimally responsive, and we have some evidence in fuel efficiency of vehicles. So this starts the process of one, at least in my mind, it starts the process of saying, yes, there's some negative cost options and there's some positive cost options, and let's ask which one of them will be fully responsive to market forces if we get the market forces in place, and which ones won't, because if we start designing interventions, we should start knowing which ones will be fully responsive to one type of intervention versus the other. So this is our first attempt. But if I go back to the McKinsey, there's something stressful about this. And that is if you did, you had essentially the equivalent, not displayed this way, done by people here in Lawrence Berkeley Labs as well as others 10, 20 years ago, and it looked about the same. Lots of negative cost options that were still there. Now, if you're talking about low-hanging fruit, or as your ex-director, Steve Chu, used to say, well, it's fruit that's fallen on the ground, and it's still there 20 years later. There must be a reason it didn't get picked. It's not enough to say, these are negative cost options, so let's do it. People here, LBL, have been saying that for 20 years, that these negative cost options. And if we haven't done it, we've got to start paying attention to why we haven't done it, which is going to keep getting back to saying there's a group of both market institutions, market failures, as well as behavioral issues that we need to take into account really fully if we're going to solve the problems of energy efficiency. It's not simply enough to say that we've got these low-cost options. The relevance of that, one of the relevance of that to an institution like mine at Stanford and yours at LBL is that there's a very large number of people who work on energy technologies, And it's been really a pretty minimal degree to which a broad range of the behavioral scientists have really gotten involved in energy issues. You know, if I did a Venn diagram, there'd be no overlap between those two virtually. And yet we've just identified a lot of things over time that if you look at just the pure technologically based economic analysis, it should have all happened, but it hasn't over 20 years. So you got to say, well, I have to face the reality. If a lot of things didn't happen, there must be a reason. One reason is maybe the analysts are all wrong. Maybe the analysts are wrong. It's much more costly to do these things. I don't think that's the answer. I think the answer is there's a group of behavioral issues that are important to pay attention to it. So that's the question. Why do negative cost options continue? And I'd like to think about both, separate out market failures and a set of behavioral issues. A lot of people talk about market barriers. I actually used to use that terminology, and I'm deliberately trying to throw it away because market barriers can mean anything that causes you not to do something. And sometimes a market barrier is this technology is simply too expensive. The benefits don't exceed the cost of adopting, and you shouldn't adopt that technology. So in market failures, in the energy area, I've just listed a group of them, and I want to talk a little bit about some of these. And I think that these have all been well identified in the economic literature. But all of these can lead to things that are in that upper right-hand quadrant that would be economically efficient to do, that would reduce energy use, but it's not being done because of the workings of the economic system. Talk about externalities. I'll talk a little bit about principal-agent problem. Poor information. Notice I have them on both sides because it's both how markets work and how people process that's really important. Some incomplete markets for energy efficiency, some systems issues, and sometimes it's the regulatory and fiscal policies that get in the way. Like in our Y2 E2 building, very energy efficient building, people wonder why there's all of these lights on in all of the entry halls in the middle of the day when it's been designed for lots of natural lighting. It's because the law of building codes force us to have them, because building codes are designed for a different type of building, and we couldn't get the dispensation to not have them on because the building codes require that. Wiring in buildings. Wiring in buildings, we define the size of wiring. It's been designed so the building doesn't burn down. You don't want too much electrical resistance. Yet bigger wires, in many cases, would have less electrical resistance and have less economic losses than the additional cost. But the building codes are designed only for safety traditionally and haven't taken that into account. That's what I mean about some distortionary policies. Then there's the behavioral issues. I'll talk about the key issue is that for most consumers who are not energy aficionados, which is most everybody, there's a low salience of energy issues. Less technical terms, they don't care. It's not important to them. Even a lot of institutions for which it should be important, actually it turns out they haven't walked the walk themselves, and Stanford's coming to grips with this and is now taking a lot of steps in walking the walk there, but it's not where their head is at, because there's other things they view more important, and yet there's good opportunities for economic saving. Poor information, and then cognitive skills. So let me start talking about some of the externalities. And I'll just go really quickly over some of the things, because a lot of you know all of this. Global climate change, we don't price carbon. We should. Therefore, we're underpricing it, and anything that's underpriced gets overused. So we overuse the atmosphere as a place to put in carbon dioxide. R&D externality. Let me take the automobile risk sharing. This is an interesting one that a lot of people don't think about, but they probably do it themselves. When people buy cars, one of the things we know is they pay attention to the safety of the cars. The parents who say, I want a safe kid so my car, so when my teenagers drive it, there's a reasonable chance they'll have an accident. I don't want them to get killed if they have that accident. How can you fault anybody for that? We all think that way, pretty much. Second part of it is that you say, well, a bigger, heavier car is less likely to get killed if they have an accident than a light car. If your kid's driving a Hummer and somebody else is driving a smart car and they hit at 30 miles an hour, we know who will die and who will live. So that you say, okay, we'll buy the larger car so that my kid's safer, and I'm safer maybe even, too. The best evidence, the best research we have says that when cars get heavier, it is absolutely true that the ones in a heavier car are more likely to survive on head-on collisions, but that the number of deaths don't go down, just who dies. So if you're getting a safer car so your kids are safe, and you get a heavier car, you know you're not going to reduce the number of deaths. You're just going to make sure it's somebody else's kid that gets killed if there's an accident, not yours. That's what classic prisoner's dilemma issue. We're all spending more money on heavier cars and using more fuel so that other people's kids will get killed rather than our own if we have an accident. Now, how can you fault anybody who would rather have somebody else's kids killed rather than their own? Now, you who have thought about the safety of cars probably didn't use those words to think about your decision. But if you want a heavy car for safety, that's really what you're doing. You're transferring the risk to somebody else, and that I view as a sort of a market failure. R&D externalities. Anybody who works in an R&D lab understands that the whole benefits of research and development typically don't get captured by those who do the research and development, and that's why we have governments that actually fund R&D in given areas. Building construction. We know about the difference between ownership of building and construction. There is some data on just use of existing buildings in California of rental versus owner occupancy. A study by the California Energy Commission that takes a group of energy efficiency options. You got to be a num-dum to not insulate the attic of your house. Insulated walls are more expensive. Programmable thermostat. These are all energy options that I'll argue are energy efficient in my definition of it. The blue's owner occupied, the purple's rental. So you take insulated walls. If people own their home over, insulated attic. If you own it over 80%, insulate their attic. If it's a rental, under 40% insulate their attic. So you can say, well, that's the data. My interpretation of that data is why. Well, you rent a house and the people, a tenant, pay the electric bill and you would pay to insulate it. And so there's a disconnect of incentives. So now an economist like me would say, well, if you have a poorly insulated home, you've got to get a lower rental price for it because the markets would work well. So I think about how that would work. Somebody's going out, I got a lot of students working with me at Stanford who rent houses. They try to rent a house, and you can envision them saying, good, I'm thinking about renting it, I like your price, but I'd like to be able to inspect your attic and really, I'd like to see your past utility bill before I decide, and what answer do you think they'd get? I think it's something like, that's interesting. Why don't you do it next week after I've rented it to somebody else? The information flows are incredibly imperfect in this type of market. But why do we have out here? Anybody can change to a low-flow shower head or compact fluorescent light bulbs. Now, if you're going to rent a house for a year, you're not going to get the benefits of 8 years of life of a compact fluorescent light bulb, so it may be the economic calculations. I actually think it's more likely the importance of the default option in human choice. Again, the behavioral sciences, behavioral choices have said that if you set a default option and there's low salience to the choice, it's not, people really don't care fundamentally. They follow whatever is the default option. And therefore, if the house came with incandescent light bulbs, why take those out and put in compact fluorescents? Most people just don't do it. Now, probably most people in this lab actually do it because they're sensitized to it. I mean, I've been getting rid of a lot of my compact fluorescents because I've been able to put in light-emitting diodes in place of them as the next generation technology. But I'm weird. I'm not the average person because I'm focusing on these things. So I think is that in low-head shower heads and the compact fluorescents, the difference between owner occupancy and rental is not because the people are different, but because the default option seems to matter. So I'm beginning to use in this a group of terms that are being now introduced through the behavioral sciences, behavioral economists, and saying if we're going to deal with the problem of energy efficiency, understanding the behavior of why people are doing things and they don't is fundamental key. You can't just rely upon the technology, nor you can just rely upon the economics, but you've got to have an understanding of behavioral issues in here. I mentioned compact fluorescent, programmable thermostats. That I find interesting. First, there's only about 60% even of owner-occupied homes have put those in. This was 2004. I don't know how much has changed after that point. But there's been a survey done of people who have programmable thermostats. 80% of them have never been programmed. Well, you laugh. How many of you used to have a VCR? You hear me? Well, I mean, look at that's Alan, you're passe anyway. How many of us still flash 12, 12, 12? Okay, the laugh means you actually know the phenomena of you get it and you don't do anything. Well, you know the default, people stay with the default. So what's happened now? Used to be the default was a programmable thermostat was same temperature all the time was the way you bought it. Now if you buy a programmable thermostat and you turn it on, there is a default setting, but a default setting is it's warm from about 6 to 8 in the morning, then it goes down for most of the day, and then about 6 at night it goes up again, and about 11 it goes down again. There's been some EPA has been very involved in setting the default options for programmable thermostats. So now if you recognize that most people never program it, and you recognize there's low salience, you start designing an intervention that says, how simple. You just make the default option the answer you'd like them to have. And you have a sensible set of programming for the programmable thermostat. So I'm talking about market failures, or I'm talking there about behavioral issues. They both give you a key to understanding why a lot of the low-hanging fruit is not picked, but start giving you a key to how to make sometimes very simple design changes so that you exploit the behavioral issues in order to get the answers that you want. And so what I think about now for futures of organizations like ours at Stanford, maybe yours at LBL, I don't have much to say about that, but is that as we move ahead towards energy efficiency and renewables as well, we've got to pay attention, yes, to the technologies. You've got to get them right. But yes to what the economics are, and yes to those behavioral issues that make a fundamental difference as to whether these wonderful technologies are adopted or not adopted, or when they're adopted, whether they're actually used in the way that you designed them and take the programmable thermostat. So let's go on. Principal agent problems. How many of you have a video recorder? Now we've got all digital, and I have a Comcast system, and I have a Comcast video recorder that, records some of their wonderfully enlightening programs on television. So it doesn't record very often. And it actually records some junk, too. I go around, I've been able to meter, and I've tested a lot of these things. And the interesting thing is that, to me, is that when that's off, it draws about 60 watts in the off state. I mean, I turn the button, it's off state. So why is it? Well, they've designed it so that the hard drive keeps running, even though I haven't scheduled for recording anything for 2 weeks from now. But they figure the startup time maybe, or the turning it on and off, so it just runs all the time. So they've designed the electronics so it uses a lot of electricity. Why? Even Ashok is surprised. He doesn't know that these are there, and he knows everything about these things. I pay the cost of electricity. They pay the cost of the box. So they minimize the cost of the box, and nobody's coming and say, I'm not going to have Comcast TV because you designed the box wrong. So that's an example of what I call a principal agent problem. I'm basically paying all the costs at the end of the day because I'm paying for their service. They're the principal who's making the decision. They're the agent that are making the decision for me, and we have a problem there. So let's put information. You all know that you don't know how much energy your television uses when it's on, and you probably don't know how much it uses when it's off. And this is an energy-centric community, and the average community, when I bought my last television, I bought this, what's called, this power meter. It's called a kilowatt meter. There's a number of them. I brought it into Fry's and said, I want this television. I'm thinking I want to unplug it. And they said, what are you doing? I said, well, I just unplug it. I just want to see the. He said, well, no. We've got it plugged in for a reason we don't. I said, okay. I put it away, and I wait till it went away, and then I unplugged it in, put it in. Okay, how many people act in a weird way like that? Not many. Almost nobody knows what the energy consequences of their choices are. But by the way, that can be different. Take refrigerators. If you buy a refrigerator, there's a big label on the front that says it's going to cost you this much per year. It's an approximation, but it's a good approximation. And it says here's the range of equivalent models, and here's where you fall in. So you got an informed choice. You have a halfway informed choice for automobiles. It gives you miles per gallon, but not a very good measure, and it doesn't really hit you in the face what the fuel cost is going to be over the life of the vehicle in any way. Televisions, you don't have that. Most of the things you purchase. When you get a new water heater, when your water heater is broken, you usually don't negotiate for the optimal heater. You negotiate for one that exists because your basement's flooding. But we don't even have much labeling on that so people know. So just simple behavioral things of allowing people to know actually can be all part of the solution. Systems as learning by doing, chicken and egg. Let me just go through distortionary policies. Cognitive issues. There's something that's really surprised me in talks that I give. I don't even think I'll try it here because it's, let me try it. I'll get a different answer here than in most places. How many of you bought a car that was new for you, reasonable enough that you remember what happened when you bought the car? Hold your hands up. Okay. Actually, a smaller fraction of people have bought cars here or participate in the purchase. Okay, hold your hands up. For those that just keep it up. How many of you knew the price of the car that you were, when you were purchasing the car, how many of you at that time knew the price of the car that you were paying? Okay, I didn't see any hands up. How many of you knew, estimated, or approximated the fuel cost over a few years of the use of that car? Hold your hands up if you did. Actually, you see, this is I knew it would be a different answer, much higher percentage. Here's what I could say if I talk with a popular audience, not at a laboratory focusing on energy. I knew it would be different. What happens is 3/4 of the hands go down when I ask about the fuel use. That is, they know what the first purchase cost is, but they didn't calculate, estimate, or approximate the operating cost over the life of the vehicles. I've asked why. How much people pay for gasoline actually has high salience. They get really upset when they spend a lot of money at the pump, but why not mostly when they purchase it? I don't have a complete answer, but one of the things that shocked me in talking individually with a lot of people afterwards, most people didn't have any clue how to do that calculation. Now, what do? You estimate how many miles you drive. Most people actually don't think about that. You take the data somewhere from the car on miles per gallon, and you can adjust or not adjust for the EPA, the bias of the calculations. And you do a division. Actually, that seems to be the barrier. Division seems to be a barrier. And then you multiply by the price of gasoline. That's a smaller barrier, that division, but it's a barrier. And then you multiply by a few years of life. Now, discounted present value, that's way out of scale. But just doing that calculation. And what I've come to is I think actually most people don't know how to do that calculation, as silly as that sounds. Now, even expressing, if EPA started moving to expressing their fuel use into gallons per 100 miles, even that means they only have to do the multiplication barrier versus the division barrier. And if there was a big label on all of them saying, if you drive like the average person, it's going to cost you this much for gasoline, that would be even better. So I think if we recognize that there are behavioral issues, then we can start designing interventions, which I'll call, as part of, if you read the book Nudge, really I recommend it to all of you. It's saying there's a lot of things where you can give people free choice, but you nudge them in the right direction, and it makes a lot of difference. These are all nudges. So let me just jump ahead. So how to deal with the problem? How much time do I have? 5 minutes before I end? Okay. I don't know. But I got some clues, and I hope other people really do some serious work and research in trying to pay attention to these things. But I have some analogies, and it's cigarette smoking. When I grew up, everybody smoked in my high school. Basically, I smoked in high school, and most everybody did. Now we move to a nation where we're fundamentally a nation of non-smokers, not 100%, but fundamentally a nation of non-smokers. And how did we do it? How do we do that? We did not do it with one single reduced form intervention. We had the Surgeon General's warning that told us about that. We had warnings on cigarette labels, on cigarettes, so that we increased the price of cigarettes, heavy taxation to have an economic incentives. We put guilt trips on people for not only what they're doing to themselves, but the secondhand smoke that they're killing their children. Carefully designed guilt trips. We have advertisements, you know, Grim Reaper advertisements that associate death with cigarettes. We make it difficult for people to smoke in bars and public buildings, and it not only protects the other people, it makes it harder for people to be a smoker. We have taken many interventions simultaneously and didn't rely upon simply one. And I think about, as we go forward in energy efficiency, because of the relatively low salience for most people, I think that we're going to have to think about designing multiple interventions. I give an example, something in an entirely different area from the medical field. Telenovelas. Some of you may know about the telenovelas, they're Mexican soap opera. They're completely steamy. They're as steamy as you could envision as a soap opera. Everybody just about to have, or is having sex in them. So completely, but it's safe sex for the most part. And so you ask, what's going on there? Why do I think about energy efficiency in telenovelas? As I said, I'm sometimes weird. Here's what I think about it. Is first, those actually, although they're about 80–90% just entertainment, they're a very important part of social messaging. And the social message is two things. Avoid sexually transmitted diseases and avoid unwanted pregnancies. So, you have three different types of characters in those telenovelas. One is what I'll call the good guys. They have at least as much sex as everybody else, but it's always safe sex. Good things happen to them. They never have unwanted pregnancies. And actually good things totally unrelated to them happen they get good jobs, they win lotteries, good things happen to that. Then there's the bad guys. The bad guys have lots of unsafe sex. And some of them die off of AIDS, or some of them have to deal with problems of unwanted children, and other bad things happen to them in the movie. So the message that is brought across to them is bad things happen to those who have unsafe practices. And then there's the third type, the transition characters. They start out as bad, and then there's a process in there where they see the light. Somebody's talked with them, they understand what they should be doing. They change behavior, and bad things stop happening to them, and good things start happening to them. Well, the World Health Organization has studied this carefully and have concluded that this is one of the fundamental things that has reduced the sexually transmitted diseases and unwanted births in Mexico. Not down to zero, definitely, but it's been a very fundamental change in the existence of these telenovelas. Now, I'm not sure how we can exactly translate that to energy efficiency. I think creative minds can think about how to have putting in this curly light bulb into has become a sex symbol somehow. But the point is, in other fields, in the health fields, well, we've actually funded very intensively the behavioral research in these areas. People have designed interventions that matter a lot and make changes. I think the type of research and thinking in these behavioral areas linked to energy technology and economics could have equivalent payoffs in the energy area. We just got to do it. And government agencies have to understand that it's worth funding that type of research. So that, I think, is an analogy. So when I think about doing this, I think that there's lots of levels of interventions. And once we know all of these market and behavioral failures, we can start designing interventions aiming at those failures. And in combinations. Some are at the policy level, some are the physical environment. You know, you design a city to make it easier to ride bikes, and people ride more bikes, and we see that in many European nations. That's sort of the physical or technology. But going down to the individual level and groups, interventions in schools, community groups, social networking messages. For example, like flash mob. They negotiate for businesses to do some good thing and negotiate that if the one who wins the contest will get a flash mob there that sort of buys out everything that they have in the store. Good economic incentive. Anyway, I should end. I'm being nodded at. I'm running out of time. The message I want to leave to you is, if we're going to deal with these issues of energy efficiency and take that low-hanging fruit off the ground, we really have got to be paying attention to research and technology, policy and regulations and rules, economic incentives, and the behavioral interventions. And I focus more on behavioral interventions because you, like us at Stanford, tend to have much more of the physical scientists and engineers working in this area. We at Stanford now are getting a group of people in the behavioral sciences involved in it. And it's been very, very exciting to see that it can happen. So let me stop at that point and turn it over. I've run out of time, but maybe we have some time for questions. Some time for questions to leave it open. Thank you.
Actually, I'm delighted to say we have some 10 minutes scheduled for questions.
Great. Somebody other than, I was going to say old friends, but I like to say long-term friends because old friends is seeming too much like reality now. Yes. Help me a little bit by giving your name as you ask the question.
Marianne.
Oh, hi, Marianne.
Hi. So my question is that the smoking example and even the sexually transmitted diseases, there's a lot of personal issues with the messages from the government.
Yeah.
And energy, we don't have that as much because you don't see the consequences, maybe on your utility bill, but certainly not at the environmental level as much. So what are you thinking about messages that have more to do with your societal responsibility?
Well, actually, in a lot of the messaging from smoking has to do with what your effect is on others as well. It's not just on you. I mean, you see this secondhand smoke discussion. So there's a reason that's included because that's part of the motivation. So I think, yes, it's somewhat different, but not quite as different as you've been indicated. But I think in this whole area, we've done basically nothing for messaging from the government. We have some messaging from the local public utilities that can roll in the cost of it into as part of their energy efficiency incentives. And we have the Flex Your Power things coming from the state of California. But for the most part, we don't have the degree of social messaging of any kind that's coming on the energy efficiency area. Or what we've gotten has been pretty primitive. And so I don't know what it takes, but I do know that there's also an economic incentive. Most of these things that we're doing, what I call economically efficient, for most of them, you're not counting just the environmental and other benefits. For a lot of these energy efficiency technologies, it's actually the economics of the individuals. That's certainly true for automobiles. So I think in designing the social messaging, you can have both parts of it. But it goes back to what I said at the beginning. I don't know what's the right social messaging and how to do it. I'm communicating a lot of my ignorance to you. I'm just saying, just as as most of us didn't know about how to develop various technologies and how to develop economics, we've got to put sufficient attention to designing those as well and moving forward. Thanks. Who else? Yes. Either. You negotiate between you two quickly. Name first.
I'm sorry, I'm Karina Gerbisi. To some extent, I think public television is starting to do that. I've been in this field for 27 years. I have my aunt lecturing me on how we're killing the polar bears, and we've got to start changing our behavior. So I do think it is starting to happen. But I wanted to say that I think there's also another major issue that explains why we haven't picked up the fruit that's lying on the ground. And maybe you would roll it into principal agent issues, I'm not sure. But it's just politics. Who's invited to sit at the table? The utilities have had disproportionate power in how we have crafted energy programs. And we see it now in how smart grid investments are made as opposed to microgrid investments, regardless of where the greatest gains could really be. So I think that politics is really important.
Right, and you raise a lot of important issues. First, let's go back to television and the smoking example. When I grew up, everybody sophisticated in movies and television smoked. Now some people do smoke in television and movies, but it's almost exclusively the bad guys. This is not an accident. This is social messaging. If the bad guys are the ones that are smoking, that's giving you a subtle message. So yes, it's happening, and it's happened a lot in the smoking example, and it's beginning to happen in some of the advertisements. But the product placement and the sort of more subtle messages to the movies haven't, to my knowledge, happened in the same way as happened in smoking. So that's a mañana thing. That's something I hope will be happening in the future. You talk about the role of the utilities, and first issue of investor-owned utility is they're investor-owned. They have an investor and they have profit incentives in their businesses. They're regulated businesses, but they're businesses. Therefore, if you understand that and you know that they respond to incentives, you start designing things to get them to respond to incentives. And California has actually been really ahead of the pack on that. Two things that we've done. One, decoupling. The profit that investor-owned utilities get is now completely decoupled from their sales of electricity. At the beginning of the year, there's a regulatory hearing that says, here's how much profit you could get, and here's what the rate should be. And so if you sell less electricity, you don't recover some of your fixed costs. But at the end of the year, there's a true-up and that's put into account, and you get whatever you lost with interest in the next year through the additional prices. So there's no incentive to now sell more or less electricity for the way we've chosen to regulate in California. Then second is the energy efficiency proceedings, so that utilities now in California have an energy efficiency target for to work with their customers. If they get less than a certain fraction of their target, they're penalized in terms of their bottom line. There's a flat region where they get the same bottom line. Then above a certain level above it, they get 8% of the total estimated net public benefits. They go directly to their bottom line. They now have religion. They understand that this is one of the most profitable things that they can do at the margin. Therefore, they've had religion. So that changing the incentive for businesses changes how businesses behave. So you call it politics, I call it economic incentives. People like Ralph Cavanagh at NRDC sort of pioneered a lot of the thinking in California. A lot of the other states haven't done that, and that could happen in other states as well. So I think that here, too, getting the incentives right, there I don't think it's so much pure behavior. That is just pure get the incentives right, and their hearts and minds will follow. Anyway,
One more question.
okay, maybe a shorter answer. Yes, up there.
I'd like to comment on connecting externalities to policy, and especially long time cycles like climate change that are beyond a political cycle or a business cycle.
You know, that's really hard to do, and that's absolutely important that we do accomplish that. And you look at the debate about carbon dioxide. I personally believe that sort of a fundamental basis of the economic incentives is getting the prices right. That is, incorporate those externality prices into the prices we pay for every good and service that we make and every decision, so we're not just separately accounting for that carbon dioxide, but it is rolled in. But you understand how that can easily be labeled as just the cap and trade tax, and we don't want a tax in there. And in fact, this whole thing has gotten a Republican-Democrat sort of spin in that the Republicans are now pushing back against it. I find that being very, very, very sad, because I actually believe that, as a Republican myself, that some of the values of the party were preserving what's important. Some of the things that's your own environment is a part of our natural heritage. And so I just don't understand how it gets to be Democrat versus Republican. But what we've seen is it's gotten so highly partisan, partly because there's big economic consequences that people get lined up. I don't have a good answer for changing that, other than I have a belief that each year we're getting closer and closer to a solution, and that within a few years I believe that we'll incorporate that element of price of the externalities. We have in other areas, in sulfur dioxide emissions, for example, we've done it. We've done it in the Montreal Protocol, but this is more by regulations, but financial incentives for not meeting it. So I don't have any simple answers on how you get the politics right. But I think that that's something that we need to keep working at the same time that we're working at these other interventions. As we notice that we're in the backdoor way getting some of these externality costs in it by having regulatory interventions to try to cause you to do some of the same things. I personally would advocate getting a set of different incentives where you match the failures to incentives and you get the prices right, and then you understand where the market will work and where it won't. But if you can't get that, well, then you may want to go to some of the second best alternatives. Okay. Do I have to stop?
So, well, there's probably, I'm afraid so, yeah. We are still
Okay, thank you.